Okay. The third component, as we discussed, Scoop. So it's a tool which is used to transfer the data between the Hadoop and the relational database. One interesting part about the Scoop is it can do both to and fro. Okay, so if I have a relational database, let's say SQL Server or DB2, Scoop can be used to get the data from them into the Hadoop, and it can also be used to push the data back to them. So it can do both at to and fro. So it can do the import as well as the export, right? So this capability is very, very important because sometimes you might have a doubt, like, okay, I have a data in the Hadoop. How do I push the data to the external world, right, or some external database to the external world? So Scoop can be used for both to and fro. Import as well as export both can be done by the Scoop. And then we have the Flume. So it's kind of a streaming data ingestion. If I'm having, let's say, data coming from 20 different servers, let's say some website is running on, let's say, 20 server. Okay, I want to get the log of all of those server to the Hadoop. So what I will do, I will run the Flume agents on all those 20 servers. Those agents will be sending the data to me in a real time and ingesting directly into the Hadoop. So those type of use case can be very well served by the Flume. Okay.
So, Dheeraj, just one question here. How basically your HBase is different than Scoop and Flume? Just because of Scoop, as you mentioned, it is for structured data and Flume is for unstructured data. But HBase is able to do both the things, it
No,
seems,
no,
right?
no, 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 no. See, HBase is a database, no
Okay.
SQL database, and Scoop and Flume are the ingestion tools.
Okay.
Ingestion tool means something which is working as a postman. It is getting from someone and it is giving to somebody else. Okay, so Scoop is getting the data from your database, relational database, and giving it to Hadoop.
Mm-hmm.
But it is not storing anything. The Scoop and Flume, they are not storing anything. They are just working as a bridge to do the data flow.
Okay. Okay.
Okay,
Yeah,
but
Dheeraj, I have a small doubt.
but
Yeah, continue,
but
continue. Dheeraj.
but HBase is a database which is storing the data. It is storing the NoSQL as well as it might store the structured data, right? So now is the difference clear now?
Means HBase is the database for HDFS, are we saying? Just because of why I got confused,
Hmm.
the HBase PPT, sorry, slide is showing that stores data in HDFS.
Yes.
So I was thinking it is also working as a data transfer only.
No, no. If you really did you work on any database earlier?
Yes,
Like,
Oracle only.
very good. So Oracle, where does Oracle stores the data?
At server level?
Server level, right? So that's what HBase do. So HBase stores the data on the HDFS,
Okay. Okay. Okay.
right?
So
So
HBase itself is a database the way other databases are there, and the way other databases store data like normal file system.
hmm,
It does not use the normal file system, but it uses the Hadoop distributed file system. Is that correct?
that's absolutely correct.
Okay.
Yes, Dheeraj. Actually, you have mentioned that HBase is a NoSQL database, that is, which stores only the structured and the semi-structured data, right?
Hmm.
But whereas the Flume, it is used for ingesting the streaming data, which is not the unstructured data. So where are we storing this unstructured data?
No, no. Flume can be unstructured data. Flume is usually used for unstructured data only, but
Yeah.
yeah, it is Flume is used to get all the unstructured data itself. Okay,
I- I-
so yeah, yes, it is used to get all the unstructured data, but you can store the data in the HDFS. So usually Flume can directly store the data to the HDFS. Okay,
Okay.
And once you have the data in the HDFS, then you can think of how you want to process it and what you want to do with it after the next step.
If I'm not wrong, we are using HBase as the storage in HDFS, right?
I didn't get this. Can you repeat that?
For the storage of data in HDFS, we are using HBase database, right?
No. It's just the other way. For storing the
Okay.
data of the HBase, we are using HDFS.
Okay.
See, HDFS is a file system and HBase is a database. So any database will not store the data within it. Database also needs a file system to store its underlying data. Like in Oracle, you have your table representation, everything is good, but underlying everything is stored as the files. So similarly, HBase is kind of a database, but underlying storage for that database is again HDFS. So HDFS is a single file system in the entire Hadoop system. There is nothing else. All the data finally will be stored on the HDFS itself.
Okay. Thank you, Dinesh.
So there is one question I have. So when the other tool that we have, Hive, where actually we fire the normal SQL statements. So does it go to HBase or directly to HDFS?
It directly go to HDFS because your files are stored on HDFS only, so it will go to HDFS.
Okay, so Hive internally does not use HBase. I mean, it directly goes to HDFS.
There are connectors, so you can store your Hive data, so that you can have a connection between your Hive as well as HBase as well. So what it will do is like for storing the data, instead of storing the data directly on the HDFS, it will be storing on the Hive. Sorry, on the HBase. You can do all of that, but by default, Hive will be storing the data on the HDFS, and any query that you run on the Hive will go to HDFS only.
Yeah, so query, when we are firing the Hive query, it is not going to HBase. I mean, it has, or can it go to HBase also? I mean,
No.
can I retrieve data from HBase using the Hive?
Yes, you can do that.
Oh, I can do that.
Yes, you can do that. So there is a way to connect your Hive to the HBase and retrieve the data. You can do that, but you have to do some additional steps and some property configuration to do that. But by default, Hive will be storing the data in the HDFS.
So
Sorry, go ahead.
Yeah, so my question was like, when data is already, I mean, when we have HBase database which actually stores in HDFS, so maybe like using Hive, there is no point of getting data from HBase, but we can directly get from HDFS.
You can think about that. Yeah, you can say that, but there are some use cases where you have to, because see, HBase, getting the data from the HBase is faster than from the HDFS. Okay, HBase has its own advantages. HBase has the way it stores the data is completely different. The way it is stored in the underlying file system. Just assume Oracle, right? If you retrieve a data from Oracle, run a query in the Oracle, it will be giving you a query much faster than if you go write a program which reads all this Oracle data file and give you the data. Just think the difference, right?
That's correct.
So that's the difference. So if you have a layer on top of your file system, it will be storing some of the data in the memory, and which will cache, and it will give you a much faster result.
But Hive itself has its own algorithm to read from HDFS, right? I mean, the way HBase will be having.
Yes.
So what I'm saying, my query is Hive SQL, right? Hive SQL,
Yes.
right? So,
Yes.
but I'm not reading from HDFS directly. I'm just writing SQL.
Yes.
And
that is true.
internally, actually, Hive goes to HDFS and retrieves data. But if I write SQL to read it from HBase, then isn't it like an additional layer is there, and there may be an overhead?
No, there will be no overhead. Well, yeah, if you really think, because see, what happens is there will be some overhead which HBase has to do, which anyways it will be doing while storing. If you store a data in HBase, it will maintain a layer on top of your HDFS, right? So the overhead will be like instead of getting the data directly from the HDFS, you are getting from the HBase. So that will be a little because that overhead is already maintained by the HBase. So Hive don't have to do that overhead, right? What
Yeah.
whatever program you are running, like whatever query you are running, that query will run as is. So there will be not much of the overhead for the Hive itself. Because
Okay.
retrieving the data, like HBase is handling all that overhead. Hive don't have to do any extra thing. But
Sure. Thank you.
but most of the cases, Hive is used to store the data directly on the HDFS. There are very few limited use cases where Hive is pointing to HBase table and doing. You can do all of that, but there are limited use cases. And if Hive is doing that, it's just kind of a layer to retrieve the data from HBase. The underlying storage is going to be of HBase, and file system is again going to be HDFS.
Yeah. So technically, Hive supports HBase, but mostly use cases is reading directly from HDFS.
Yes, that's true.
Okay.
Okay. There are Zalil. Actually, in the HBase, we talk about like a table can have thousands of columns. So how do we differentiate? I mean, in RDBMS, columns are actually basically unique, right? So it will each column maintain only one set of data. Okay, but when you come here in HBase, is that same logic is applicable in HBase columns, or is it something different here?
It's something different. No, it's exactly different. So the concept of the column in HBase is not the way it is with the relation. So in HBase there is a concept of column family. Okay, column family is kind of a related group of the column you combine together and create a column family, and you create multiple column families. So HBase is kind of a very dynamic. So let's say there is a column family with person's information. Okay, so today you are having personal information like person's name, age, address, this type of information you have some person. But tomorrow you are getting some more attributes to the person. Let's say his mobile number and Aadhaar card number, for example, right? These are new attributes which has to be added to a person. So dynamically you can add number of columns to a person's column family, right? And that dynamic addition is on a runtime. So you don't have to again drop a table, recreate a table, all of that. Nothing has to be done. Just say 2 more columns added, dump your data, it will automatically add the columns and it will dump the data. So it's very flexible column addition in a runtime. It's completely different from the way how RDBMS works.
Okay.
That's
so
why
in that case, yeah, I understand. Okay, in that case, for example, column family, I have one employee. Okay, some name is available. So throughout the life, column family of the employee will always contain employee name. Is that understanding correct?
No.
Or is that something employee may contain some other detail also apart from the employee?
No, by deciding a column family, you have to group your columns within a column family. So if employee name is part of the column family, it will always be like that.
Okay. Okay, fine. Yeah, thanks.
Yeah. Okay, very good. So let's quickly go on to different concepts. The next one is the Spark, and let me tell you, Spark it's not been a very long. It's just been 2 years, I would say. And in the 2 years, Spark has got the maximum market capability, and a lot of companies have started using this Spark. And the reason why Spark is so popular is because it is 100 times faster than the MapReduce, the traditional MapReduce. Right? So when earlier Hadoop was made, maybe 5 years down the line, it was only doing the batch processing. And it was very slow. With the introduction of these new components like Spark, Storm, all of these things are making it run very faster. So all the use cases like Spark streaming, machine learning, graph processing, all of these things are possible because Spark has been introduced and it has the capability to perform a lot of in-memory computations in the processing. Right, so that's what is about the Spark. It is mostly used to process the data. And next we have MapReduce. So this is kind of the traditional way of data processing, right?
Dheeraj,
Yes.
Dheeraj, do you want to say like Spark will be the place where we need to write the programs or the regular logical operations? Is it the same?
Yes, absolutely. That's the place where you have to write all your logics.
Okay.
Right. So this is the place
So
where
it's yeah. So Spark, can we say Spark is a replacement for MapReduce?
100%. Yes.
Okay. So underlying file system for Spark is still, I mean, HDFS.
Yes.
And it is just like the MapReduce component. We can use Spark.
No, it is so Spark definitely can use HDFS. Most of the workload is through the HDFS, but Spark has connected to almost everything. So anything what you can think of has Spark has a connector. So let's say you have a data in some database, Spark has a connector to that. Let's say you have Cassandra, Spark has a connector to that. MongoDB, HBase, everything Spark has a connector. So it can ideally, technically, it can read that from anywhere.
Okay. So and MapReduce is tightly integrated with HDFS.
Absolutely, that's the major difference. Right, so Spark is 100% replacement of MapReduce, you can say, but again there's a but. So Spark is an in-memory processing. Okay, you have to always keep in mind Spark is an in-memory processing. So if we have a resource constraint in terms of the memory, right, and we cannot use a Spark, let's say you have a petabyte of the data, you want to run some workload, definitely you cannot use Spark, right? So Spark and all these are limited to some terabyte range. Okay, if it goes more than that, definitely you will not go with the in-memory option, right? So you cannot store so much of the data in your memory, so the only option left is this one, Hadoop MapReduce, which is the classical one, traditional one, and something which is not memory-based operation. So it has the capability to process multiple terabytes of the data. Okay, so the way it works is like it works on the concept of divide and rule. It will break down your workload into smaller pieces. It will run them in parallel, and then results will be aggregated and we'll get the output. Okay, so that's the major advantage of using Hadoop MapReduce over Spark. Sometimes people ask, like the question which you put, like, is it a replacement for the MapReduce? Yes, till your data is you're processing a data till a certain limit. Okay. The cross question to this is like, okay, tell me the use cases where we cannot use a Spark, right? So if you have a huge amount of the data which will not fit in the memory, so you have to use MapReduce. So Spark will not come into those cases. Okay.
So it will say it's opposite, right? I mean, the way we were saying, like we were having that analogy, right? I mean, in traditional way, actually, we get the data, and like if we have Java, then we write SQL and we get the data and do processing. But in Hadoop, actually, we push our program to the data, and there actually the processing happens.
Yes.
But again, we are saying Spark is in memory. What does it mean? Does it get the data in memory?
No. In Spark also, we push the program towards the data. But this program will be running by moving the data towards the memory of each of the individual nodes. So let's say I have 100 nodes. Okay, each node is having, let's say, 2 gigabytes of RAM. Okay, so total I have 200 gigabytes of the RAM available. So if I have to run some processing, what I will do is I will start a Spark program which will consume the RAM of all those 100 nodes. I'm not moving all the data towards one particular server. What I'm doing is I'm moving my program to 100 nodes, but that program is running by taking out the data in the RAM of individual nodes and then processing it in memory. So ideally, I am bringing the data to individual nodes RAM, not at a single RAM. Okay. Over here also I am moving the program towards the computation or the program towards the data. I'm not moving data to some one place. I'm moving my program to the node which contains the data, but instead of processing from a file-based operation, I will process it in memory.
Yeah, so does it mean like in MapReduce, the program when it is pushed to the data node, it does not, I mean, it operates, it does the processing on the file system and it does not use RAM of that node?
Yes, that is correct. So the RAM will be minimal required to run a Java. If you run a Java program which is reading from a file and writing to a file, whatever minimal RAM is required, that will be required. But all the underlying storage will not be from the memory. It will be reading from the HDFS.
Yeah, so RAM is just being used only for that program which has been pushed mostly, right? And it does not bring the data from the file system to the memory or RAM. It does not do in MapReduce, but that is what is changed in Spark. So Spark brings the data in memory and it does faster processing.
Yes, you got it. 100%. That's correct analogy. That's what it is.
Okay, yeah, that's base concept, I think.
Yeah, that's the main concept. That's the major difference.